Good day, we are Group 1 from Biosymmetry A and we are to present the laboratory manual for the two equipment, the Rockwell Hardness Tester and the Magnetic Particle Tester.
Good day everyone, my name is John Carl Bisa and today, together with Claire Aubrey Altamera, we are going to discuss about the description and parts of the Rockwell hardness test. So let's start. Here is the picture of a Rockwell hardness tester equipment. About the equipment. Did you know that Rockwell hardness testing is a general method for measuring the bulk hardness of metallic and polymer materials? Although hardness testing does not give a direct measurement of any performance properties, hardness of a material correlates directly with its strength, wear resistance, and other properties. Let me give you an idea about hardness testing. It is widely used for material evaluation because of its simplicity and low cost relative to direct measurement of many properties. Specifically, conversion charts are Rockwell hardness to tensile strength are available for some structural alloys including steel and aluminum. Let's fully discuss about Rockwell hardness test. It is based on the measurement of the depth to which an indenter is forced by a heavy or major load beyond the depth resulting from a previously applied preliminary or minor load. It is the most employed hardness test method. It is used on all kinds of metals, except in situations where the surface conditions and metal structure would produce high variations. This test takes measurement of the permanent depth indentation caused by a load or pores on a particular indenter. One of the several tests aimed to gauge a material's compatibility as a component to an object based on their strength and durability. The rationale behind the Rockwell method is that the durability of a material is better gauged on its ability to maintain structural integrity from damages that are not merely superficial. Therefore, the method is commonly used in the fields of metallurgy and engineering, where integrity of a material cannot be simply observed at a surface level.
Good day everyone, my name is Claire Aubrey Altamera from BSME3A and today I'm going to discuss about the parts of the Rockwell hardness test. So the parts are the dial face, the penetrator, the anvil, the wheel, the crank or the lever, and the knob. So the dial face is where the result can be seen. Next, the penetrator may be either a steel ball or a diamond spheroconical penetrator used in the process of testing. And the anvil is where the specimen goes. Next, the capstan or the wheel. It is used to elevate the test specimen into contact with the indenter point. Next is the lever or the crank. It is used to release the major loads. And the last one is the knob. It is used to select the load through rotating it. And that's all. The next one will be discussed by my group mate, which is the how to use the equipment.
And now, I will discuss to you how to use the Rockwell hardness test equipment. The determination of the Rockwell hardness of a material involves the application of a minor load followed by a major load, and then noting the depth of penetration. The hardness value directly taken from a dial in which a harder material gives a higher number. The Rockwell hardness test uses two loads that are applied sequentially. A minor load of 10 kg is applied that helps sit in the indenter and remove the effect of surface irregularities. A major load, which varies from 60 kg to 150 kg, is then applied. The difference in depth of indentation between the major and the minor loads provide the Rockwell hardness number. This number is taken directly from the dial on the machine. The Rockwell method measures the permanent depth of indentation produced by a force or load on an indenter. First, a preliminary test force, commonly referred to as preload or minor load, is applied to a same sample using a diamond or ball indenter. This preload breaks through the surface to reduce the effect of surface finish. After holding the preliminary test force for a specified dwell time, the baseline depth of indentation is measured. After the preload, an additional load called the major load is added to reach the total required test load. This force is held for a predetermined amount of time, the dwell time, to allow for elastic recovery. This major load is then released, returning to the preliminary load after holding the preliminary test force for a specified dwell time. The final depth of indentation is measured. The Rockwell hardness value is derived from the difference in the baseline and final depth measure. This distance is converted to a hardness number. The preliminary test force is removed and the indenter is removed from the test specimen. Then you can see in the picture how to use this equipment.
So let's come now to the safety precautions to be considered when using Rockwell hardness tester. So Rockwell hardness testing involves inherent hazards from high forces and stored energy. You must be aware of all moving and operating components that are potentially hazardous, particularly the indenter. The following safety measures are listed below. So the first one is always wear eye protection and use protective shields or screens whenever any possibility exists of a hazard from the failure of a specimen, assembly, or structure under test. So it is a common knowledge that we must wear eye protection and protective shields if necessary in every material test for our safety. Next is avoid irregular shapes of specimens. Since the equipment will be pressed and is going to be indented, we must avoid irregularities in its shape because it may slip out and cause some harm. Next one is hardness test specimens should have parallel top and bottom surfaces. So yes, having parallel surfaces are for the accurate and safe testing. Next, indenter and anvil should be clean and well seated. Again, it is for the accurate and safer testing. Next is surface should be clean, dry, smooth, and free from oxide. So not just the indenter but also the surface. Next, surface should be flat and normal. And the last one, your base safety precautions would be to get training on the testing equipment you are using and study your operating procedures and reference manual thoroughly. So before you try testing the equipment, you must be knowledgeable enough because it's more safe when you know what you're doing. So that's the safety precautions to be considered when using Rockwell hardness tester.
Next is the preventive maintenance for the Rockwell hardness tester. Number 1. In transporting the hardness tester, the weights and indenter must be removed. A piece of shockproof rubber pad must be placed between the base of the indenter and anvil. It should be packed accordingly to a remote transport. Number 2 is when performing any adjustment and checks, the power supply must be cut off for safety. 3. Changing the test force is prohibited under the status of the indenter that interacts with the sample being measured. Number 4. When installing and uninstalling an indenter, much attention should be paid to ensure that the tip damage and contamination are avoided. The mounting surface must be clean. The indenter should be removed for storing when not to be used for a long time, and rust protection measures are necessary. Number 5 is the surface of the anvil and hardness reference block should be clean without contamination, scratch, scoring, and bruising. And coating of rust protection oil is necessary when installed. Number 6. The sample measured must be placed steadily when testing. Then the support should be reliable to ensure no movement or distortion during testing. Number 7. Dust-proof and corrosive medium prevention should be considered in the daily operating environment. Regular rust prevention measures should be adopted in a moist area. Number 8. Regular lubrication should be carried out for the lead screw. Note, not much lubrication oil should be dripped. Number 9. Regular verification and calibration of the harness tester shall be performed following relevant standards and rules of state to ensure the accuracy of the harness tester. Number 10. Do not dismantle or repair parts and components used for fastening and assembling by yourself when an abnormal condition occurs. Please contact the supplier.
Magnetic particle test equipment. Magnetic particle testing is a type of non-destructive testing which is primarily used for detecting cracks in the material. One common equipment used in magnetic particle testing is the electromagnetic yoke. An electromagnetic yoke is used for the detection of surface indications. It is a common piece of equipment that is used to establish a magnetic field. This type of magnet generates a very strong magnetic field in a local area where the poles of the magnet touch the part being inspected. An electromagnetic yoke contains a switch. It is included in the electrical circuit so that the current and therefore the magnetic field can be regulated by turning it on and off. They can be powered by an alternating current from a wall socket or by a direct current from a battery pack.
Hello, I am Mariel Bandol and I will introduce to you the second part of a magnetic particle test equipment. So, an electromagnetic yoke has electromagnets. The electromagnets in the form of an adjustable horseshoe magnet called a yoke eliminate the problems associated with permanent magnets and are used extensively in industry. They only exhibit a magnetic flux when electric current is flowing around the soft iron core. When the magnet is placed on the component, a magnetic field is established between the north and the south poles of the magnet. So for the uses of the equipment, basically, electromagnetic yoke is used for non-destructive testing under magnetic particle testing. It is used to detect surface and subsurface discontinuities in ferromagnetic materials like nickel, cobalt, iron, and their alloys. So it uses magnetic particles and magnetic fields to find flaws in various products. And it can also be used to determine a component's fitness for use.
Hello everyone, this is Grace B. Barbacena, and together with Alex Bigueras, we are going to discuss how to use the magnetic particle test equipment. So to conduct a magnetic particle test, inspectors start by magnetizing the material they want to inspect. If the magnetized object has no defects, the magnetic field will transfer throughout the material without any discontinuities or interruptions. But when the current encounters defects in the material, it will be interrupted, causing it to spread out from that point and create what is called a flux leakage field where the defect is located. Once the material is magnetized and defects have created these secondary flux leakage fields, inspectors spread magnetic particles over the surface. The particles will be drawn to the secondary field, gathering around it and making it visible to the naked eye. The magnetic particle inspection is performed in the below-mentioned 6 steps. First is the surface preparation. All surfaces and adjacent areas within 1 inch that will be examined must be free from rust, scale, sand, grease, paint, slag, oily films, or other interfering conditions. Unusually rough or non-uniform surfaces may interfere with magnetic particle cluster formation, making interpretations of the magnetic particle inspection method's indications difficult. Second is inducing a magnetic field. This is the most important step in the magnetic particle inspection procedure. In this step, place the equipment on the area to be tested and induce a magnetic field. Various types of magnetic particle inspection equipment are available. Widely used industrial equipment are permanent magnet, electromagnetic yoke, and many more. Magnetization technique can be longitudinal, circular, or multidirectional magnetization. Equipment spacing in the inspection area is normally kept in between 3 inches to 8 inches. An ASME or American Society for Mechanical Engineers spy gauge or bore mag castrol strip can be used to verify adequate magnetization of the part.
Number 3. Applying magnetic particles on the test surface. Both dry and wet magnetic particles can be either fluorescent or non-fluorescent, visible, color, contrast, and are available in a variety of colors to contrast with the tested material. So accordingly choose the required particles for the magnetic particle inspection and apply on the surfaces when the specimen is in magnetized condition. Number 4. Examine the component surface for defects. Remove the excess particles using light airflow and inspect the component for defects as per acceptable standards. Number 5. Repeat the test by changing the magnetic field. 2 separate examinations are carried out on each area to be tested. The second examination is performed with the lines of flux perpendicular to those used for the first examination in that area. And number 6. Demagnetization and cleaning. The presence of residual magnetism in the component may interfere with the subsequent usage. Hence, the demagnetization shall always be performed on the parts once the magnetic particle inspection is over. The presence of residual magnetism can be verified using a calibrated Gauss meter, magnetic field meter, or a Hall probe Gauss meter. Residual magnetism must not exceed plus or minus 2 Gausses. After that, the parts shall be cleaned to remove all residual magnetic particle materials. If wet fluorescent MPI was performed, the part shall be scanned with the backlight to assure that the cleaning is adequate.
Hi, I'm Madeline Ruth Asansa, and today I'm here to discuss about the safety precautions on using the magnetic particle testing equipment. So first, all electric circuits should be installed and grounded in accordance to any code applicable to the country, such as the Philippine Electrical Code. An exhaust should be provided to properly control dust particles during the testing. If an exhaust is not provided, proper respiratory equipment must be worn. An eye protection should be worn to avoid any irritating particles. And personal protection equipment or PPE should be used to avoid skin irritation caused by the powder. The wet working component of magnetic particle inspection must be physically isolated from the electrical or electronic parts according to some regulations in order to avoid injury or worse, death. Some equipment entails component clamping. The mechanism might be mechanical, such as spring-loaded device, or pneumatic. Under any circumstance, operators must use caution to avoid being entrapped and injured. Some components to be tested are heavy and when mishandled may become a hazard. Always practice caution to avoid injury. Anyone other than certified and authorized persons should not be allowed to intervene in the internal electrical and electronic components of a magnetic particle inspection device. Unqualified persons should not be allowed to interfere with any automated equipment.
And for the magnetic particle test preventive maintenance, first is the daily operator checks. Every day, the operators should perform visual inspections of exterior components of the magnetic particle equipment. Some elements to look for are wear on any wires or cables and loose connection on hoses and fittings. And the first to check are the batt level. Make sure the batt is at the right fill level. Add more batt if needed. Second is the particle concentration. Check particle concentration with the centrifuge tube.
Third is the cable and bus bar connections. Check coil, headstock, tailstock bus bar, and cable connections. Tighten if necessary. Check wires and cables for worn or frayed insulation. Fourth is the headstock clamping. Check headstock clamping action to make sure it is clamping securely. Fifth is the locking devices. Check tailstock and coil lock to make sure they lock securely. Next is to check tank hoses and nozzles for leakage. Seventh is to check air cylinder, fittings, hoses, air regulator, and speed valve for any leaks. 8 is the power indicator. Check that indicator lights are lit when power is supplied to inspection unit. Next is the push buttons. Check push buttons for proper operation. Push buttons are dimly lit when off and brightly lit when on. Next is the digital ammeter and current assurance indicator. Check ammeter readout and current assurance indicator operations. Next is checking for missing or broken filter or lamp. Check for damaged cord. Next is for the curtain. Repair small cuts and tears with black plastic electrical tape. And for the weekly operator checks, once a week, the operator should clean the contact pads or plates and clean out the pump system. Cleaning debris out the tank and changing the bath on a regular basis are critical to reliable inspections. Pumps are good at circulating fluid and magnetic particles, but they don't do so well with the paper towels, nuts, or bolts that find their way into the tank. First is the contact pads and contact plates. If water bath is used, remove oxidation from between the contact pad and contact plate. Use a wire brush if needed. Second is the ground pole interrupt. Check for proper operation of UV lamp. Lastly, the pump. Clean the sump screen to prevent loss of flow from the pump.
Good day, this is Aljon Barnedo and this is the continuation for magnetic particle test preventive maintenance. Monthly operator maintenance. Every month, the operator should check and clean the tank, fans, and air filter if necessary. Sometimes preventive maintenance may be a little bit more preventive in nature depending on the environment the unit is located in. So for example, if a certain country have a cold weather, then there should be more times of maintenance compared to the usual. So for the tanks and grills, check and clean if necessary. After cleaning, flush tank and grills with appropriate bath solution. For fans, listen for fan operation and check airflow for restriction. For air filter, clean air filter element and bowl. For pump seal, check for deterioration and wear. Look for leaks of fluid around or near the pump or motor shaft. Advanced equipment maintenance. While most preventive maintenance is simple and easy to do yourself, there are periodically more advanced maintenance checks where you will want to bring in a trained maintenance professional. So not all preventive maintenance can be done by ourselves, but we should also consider of getting help from a professional. For rectifier stock, blow accumulated dirt from rectifier heat sinks and fan blades. Do not use cleaning solvents. Do not blow firing board. For control panel wiring, check wiring for discoloration or burnt insulation, and that connectors are secure. For lower unit wiring, check wiring for discoloration or burnt insulation, and that connectors are secure. For transformers, check transformers for discoloration and pungent odor. For connections, check and tighten all connections, bus to bars, cables, and wires. For tank and plumbing, check for leaks. For fans, check that the cooling fans turn freely. For ammeter and mug shut time, check for accuracy every 6 months.
So that's the end of the laboratory manual for the two equipment. So here are the list of the references for the informations, and thank you for listening, and again, have a good day.